Hey folks, so this is section 4.1 and I'd like to introduce you to two new parents. One of them is called the reciprocal function and the second one is called the reciprocal square function. Remember that you have to memorize three things about every single parent. The first thing is the equation. So you'll notice that the reciprocal parent has the equation of 1 over x, or f of x equals 1 over x. The second thing that you have to memorize is the name of the function, so that's the reciprocal function. And the third thing is the graph, and that's what we're going to do here in just a moment. In order to take a look at our graph, let's think about some numbers that we could plug in to plot points for this first time around. So if I used an x value of 0, unfortunately 1 divided by 0 we know is not allowed. It causes an undefined place in the graph. And so what that means for us is that this is going to cause something called an asymptote, which is kind of a weird name, but an asymptote is a place where the graph is going to always be getting closer and closer and closer and closer to that, but it's never actually going to reach it. And so the way that we're going to draw an asymptote is we have to draw an asymptote for all of the places where x equals 0. So we're going to use a dashed line to show our vertical asymptote. And this just simply shows us that this is a no man's land. You can't get there. Our graph is going to get closer and closer and closer, but it won't reach it. Now, since x is not allowed to be 0, if you try to think about numbers that you could plug into our equation that would make y equal to 0, you're never going to find anything that will make y equal to 0. So we find that y equals 0 is not allowed. You won't be able to find it. So this is our horizontal asymptote. So then think about some other values that we have. If you plug in a 1, 1 divided by 1 is 1. So I have a coordinate here, which is one of my special points. And then if you think about x equaling 2, then that means our parent will be 1/2. So that would be right here. Or x equaling 3, that would be 1/3. A little shorter, or 1/4, or 1/5, or 1/6, or 1/7, or 1/100th, 1/1000th. So you can tell that it's getting shorter and shorter and shorter, and it's getting closer and closer and closer to that horizontal asymptote. So let's take a look then just simply between the numbers 0 and 1. So if you think about x being 1/2, if you plug that in, that's going to be 1 divided by 1/2, which is the number 2. Or 1 divided by 1/3 is 3. So again, both on the vertical asymptote, we're getting closer and closer and closer and closer, but also on the horizontal asymptote, we're doing the same thing. Let's go over to the negative side. 1 divided by -1 is just a -1. 1 divided by -2 is -1/2. 1 divided by -3 is -1/3. Once again, you can see that I'm getting closer and closer and closer and closer. 1 divided by a -1/2 is going to be a -2, a -3, a -4, and so on. So this is what our parent looks like. Now we know how to get domains and ranges and all of that because we've been practicing this all semester. So when you take a look, my domain is going to be -infinity to 0, 0 to infinity. I have to skip over the 0 because that's my vertical asymptote. My range, I have to skip over the horizontal asymptote, so I also have to skip over that y equals 0 value. Increasing, decreasing, and constant. Remember, we use intervals for this. And as you look at this from left to right, it's always decreasing. So my whole entire domain is decreasing. My vertical asymptote is going to look like the equation of a vertical line, which is going to be at x equals 0. My horizontal asymptote will look like the equation of a horizontal line, which is going to be y equals 0. So let's go through then and do the same thing for our reciprocal square function. So if I again take a look at my original equation, I have 1 over x squared. I cannot have 0 on bottom, so that's going to cause my vertical asymptote at x equals 0 I'm going to go ahead and write that one down. And then once again, there's no way that I can make y equal to 0 ever. So that's going to give me a horizontal asymptote at y equals 0. And then plugging in some values, if I plug in a 1 over 1 squared is 1. 1 over 2 squared is 1/4. So again, this is getting very small, getting closer and closer and closer to that horizontal asymptote. It's going to do the same thing for the vertical asymptote. In fact, this looks very similar to our reciprocal parent. However, when I go over to the other side, the negative side, 1 over -1, when I take that -1 and square it, it becomes a positive 1. So that's going to be where the difference is. So it's going to get closer and closer and closer to my horizontal asymptote, closer and closer and closer to my vertical asymptote. Once again, let's take a look at our domains and ranges. We understand these. We're comfortable with these by now. Domain, -infinity to 0, 0 to infinity. The range is going to be different because I have nothing below the x-axis. So it's just going to start at 0 and go up to positive infinity. And then for my increasing, decreasing, and constant, as I move from left to right, I notice the first thing that's happening is it's increasing, and then it turns around and starts decreasing. So it's going to increase from -infinity to 0, but then it'll turn around and decrease from 0 to infinity.